Here we go. We are live. Hello, ladies and gentlemen, boys and girls. Welcome to VUX World. I'm your host, Kane Sims, and I'm joined, as always, by your host, Dustin Coates. Dustin, how do?
Going pretty well. How about you, Kane?
Very well, very well. It's a little bit rainy today in Royal Tunbridge Wells. Doesn't look very royal outside, but is it raining in Paris?
Not right now, but I got to go outside my neighborhood for the first time on Monday, and it poured. It
Wow,
poured.
wow.
So, so
Just
it's
waiting for
telling
it.
it's telling me I need to get back indoors, I think is what it's saying.
Interesting. It's yeah, sods law that, isn't it? You kind of it's been absolutely fantastic all week last week and pisses down this week. But anyway, on with the show. And Niclas, our guest today, by the way, boys and girls, is Niclas Bergstrom, CEO of Readspeaker, and we're going to be getting into a really interesting conversation about text to speech. It's one of the core components that makes voice assistants and voice user interfaces work. And Niclas has a huge amount of experience in that field. Niclas, welcome to the podcast.
Well, thank you. Thank you. Nice to be here.
Very nice to have you here. And what is it like over there? You're in Sweden, right?
Yeah, I'm based in Sweden, in Uppsala. It's pretty quiet. So we don't have a big lockdown here, but it's yeah, people are encouraged not to mingle about in groups and take leave some space between you and the other fella. Apart from that, it's going on a bit slow, but
Hmm.
yeah.
Yeah. So what is there not many cases in Sweden? Like, is it not kind of as bad as other places? I'm not familiar with what the situation is over there.
I'm not sure. I think we had something like 2,300 deaths. I don't know exactly how many infected, but we also count all the people, all the elderly people that die in retirement homes and stuff, not only in the hospitals. Therefore, I guess the numbers are a bit higher than they are if you compare to other countries. But yeah,
Right. Cool. So how long has it been for you, Dustin? How long has the lockdown been over there in France?
Man, it's hard to say. Uh, time has no meaning anymore. I think it's been probably about a month and a half at least. It definitely feels longer, but I think that's about how long it's been.
Wow. Yes, well, there we go. Anyway, on with the show. It's been a mad few weeks, but the benefit actually of spending all this time inside is that we've done a hell of a lot more of these live streams, and we've had some immense conversations with some immense people. Nicholas being one of them. We'll get into Readspeaker and we'll cover a little bit of Readspeaker, well, a lot of Readspeaker and what it does and how it functions, etc. But before we kind of get into that, it's worth for context for the people tuning in. And by the way, for everyone tuning in, thank you for tuning in. And we're going to probably throw this open for some questions as well as we kind of go through the show today. But Nicholas, for people who are not familiar with yourself, do you want to give us a bit of a context in terms of your experience and how you ended up at Readspeaker?
yeah. So currently, I'm not actually not the CEO anymore. I'm the CTO these days. This has
Right.
changed,
Well, I
and
seen that. I seen that on your LinkedIn profile. I
yeah.
seen CTO, and when I posted today that we'll be joined by my original post was CTO, then I changed it because when I googled you, I found something that said CEO. So apologies for
Yeah, no problem. I'm flattered. No, I used
that.
to be. I used to be for many years. Yeah, well, basically, I founded the company Speaker originally in 1999, and yeah, so it was pretty much about accessibility at that time. We started to develop web reading services for websites, basically adding listen buttons so people that had difficulties to read themselves could easily consume the information. So we're still doing that, by the way. We have like 10,000 customers around the world. So we were basically developing, selling those kind of solutions, also like telephony solutions where you could dial in and listen to your email using text to speech. Back in 2001, actually. So that was quite quite long ago. But yeah, so after a few years, we started to develop text to speech technology. In the early days, we licensed the third party text to speech. Um, and what happened in a few years ago, it was that we were acquired by Hoya, which is a huge multinational Japanese company, and they had a couple of companies themselves in text to speech, being NeoSpeech in the US, which is a quite famous name, and also VoiceWare in Korea, where most of the technology was developed. So we have merged together our businesses, and merging also our technology base. So we're now still what we're doing now basically is we have these web reading services, we have solutions, text-to-speech solutions for education, distant learning, learning management systems. Um, we develop core technology, text-to-speech, using various technologies. I will come into that later. And yeah, selling server and SDKs and cloud solutions. So we've been in cloud solution provider since 1999.
Wow. And what kind of got you into it then? Where did your sort of like personal journey come into text to speech, and what interested you about that in the first place to go ahead and then create a company that specializes in it?
Yeah, I've always been very interested in technology overall, and I have a background of recording engineer and a lot in the music industry, also in sales and marketing. So I was working at this other place before 1999, and then me and some friends, we thought, let's see if the web could talk. I mean, who could benefit from it? So initially, we thought about this is going to be a lot about recording people, recording, you know, yeah, having text speech enabled by real people. But obviously, the web is pretty dynamic in nature. Text changes all the time. So we started to let's use text to speech technology instead, which was kind of robotish at the time. Um, but really, the heart of in my journey, what's been most important is that in the ways that the text to speech technology can really help people. It can really make things accessible, which isn't if you don't have this access to these technologies. So really, yeah, making use of the technology to make the world a better place has been really been my heart feeling. But I mean, yeah, so the journey has been long, and a lot of things have happened, especially in the last few years. And I'll be happy to talk a bit more about that. Yeah.
Cool. Let's do that. We'll do that in just one moment. But first, quick shout out to Denise in Dallas, who's tuning in from Texas, Kirsten in NYC. We've got Ahmad from Berlin and Raymond from Barcelona. So thank you everyone for tuning in. If anyone has any questions about text-to-speech technology, use cases, applications for Niclas, then please do drop them in the comments, and we'll get round to that. So you were hinting at there, Niclas, the kind of history of text-to-speech and where it's come from and what the developments have been. What is the kind of I mean, honestly, Dustin, I know that we talk about the history of voice assistants and stuff like that, and kind of like what the past was, and we had John Bloom talking about where things were in the past with nuance and stuff like that. But I don't know, from your perspective, Dustin, have you got any kind of prior experience with text to speech beyond or before the kind of starting the podcast and doing building Alexa skills, etc.?
Not much. I would say that text to speech almost feels like the if you've got a trifecta of voice technologies with speech to text, the NLU, and you've got the text to speech. The text to speech I feel like is often overlooked, and I think you're probably going to tell us that it's wrongly overlooked, but I think it's definitely one of the ones that's most overlooked, perhaps because the other two can fail so spectacularly, whereas the text to speech, it's going to fail like every single word, and it's going to be not as powerful as it can be, but people maybe feel like they can get away with something a little subpar.
Yeah.
Yeah.
So,
Would you say that's fair, that it's a little bit like, so you mentioned your audio background, and we've had discussions with a lot of audio engineers on the show, and they always reference the 5 A's: audio as an after, or was it the 4 A's? Can't even count. Audio as an afterthought, in that audio is crucial and so important, but people tend to think about it last. Is that kind of the similar kind of thing with text to speech, or do you think that it is in the industry on an equal footing with the speech recognition and NLU?
well, I think I mean, if you look today at all the voice assistants are out there, like you say, you need speech to text, you need to have NLU, you need to have text to speech, and everything should just work, right? But I mean, in that context, I mean, speech is the only not silent technology in that mix. Everything else should just work, but the thing that you're really communicating with as a user, I mean, the user experience is that you talk, you just assume the system will understand you, and when the system talks back to you, that is sort of where the interaction really happens. So I think it's really important to look at, to have to maximize the user experience by having the appropriate text-to-speech voices, having branded text-to-speech voices to stand out from the clutter, because um, now all brands or companies, they speak with the same voice more or less. If it's on Google Home, it will be the Google voices, or Google Assistant. It will be with the Polly or Amazon voices when it's an Alexa device, etc. So yeah, I think it's really important. It's also a bit tricky because it's when you do text to speech, you are sort of, yeah, you make creating synthetic speech, and your brain is really sensitive to distortions, or if something is pronounced very strange, or something is yeah, not read correctly. It sort of tricks the brain a bit more than if the other technologies, speech to text, NLU, they are, you know you don't experience them, right? You experience the speech, and your brain is very picky on that subject.
That's a very good point, because
Yeah.
we're so used to speaking to other humans that it's probably more prevalent, isn't it, when we hear something like text to speech, or we hear, because there's some examples of, I mean, Readspeaker, I've sponsored the podcast in the past, and we've had a close look at the kind of text to speech that Readspeaker produces, and it is pretty good, but there is some fairly kind of subpar solutions out there, which you can tell a mile off. It's really obvious. And going back through the kind of, Readspeaker launched in 1999. There's been huge progress since then. There was still things going on before then. You look right the way back to, the shoebox and things like that, of like in 50s or the 30s even, in trying to get computers to talk. What's your experience been like, either from 99 to now, or even before then, of text to speech solutions? How would you summarize the journey it's been on and where it is now?
Yeah, I can just add that, I mean, the first text-to-speech sort of system was, or yeah, it was an attempt made in 1779
Wow.
already, with a mechanic TTS, with acoustic resonators like a human vocal tract, and resonators with vibrating reeds like like a saxophone. So pretty awesome. But yeah, like I said, Bell Laboratories, around mid 30s, they made the first real progress in speech synthesis. Uh, and then, I mean, the first full text-to-speech system was developed in Japan in 1968. And then after that, like in 70s and early 80s, there were a lot of commercial players that started to develop text-to-speech, like Texas Instruments with a Speak and Spell. Also, what's it called? Kurzweil had this system, because it was mainly research at that point. I mean, see, you know, how can we mimic the human voice, electronically, basically. But I mean, the first use cases, apart from the Speak and Spell boxes, I don't know if you remember them, was the Kurzweil, the reading machine for the blind, which was really an optical scanner with sort of, yeah, OCR and speech capabilities. So I mean, initially, and especially because the speech was of such a, I would say, special quality and quite robotic, it didn't appeal to most people. But of course, for people that were blind, visually impaired, this was a big game changer for them, because all of a sudden they can actually use systems that they couldn't use otherwise. I mean, all the use cases initially was really in accessibility, in assistive technology and stuff. And that also, when I started, of course, they were text-to-speech system used in IVR systems, so telephony systems, touch tone, yeah, simple switchboards. Um, and I mean, we were the first one to introduce the speech as a service on the cloud, even before cloud was a thing. Even broadband internet didn't really exist at that time, but that enabled also people to add text to speech very conveniently in their web applications, or later mobile apps. So I mean, we've seen the development. I think with first comes accessibility, then comes use cases for telephony systems and for mobile. And what happened then next, I would say the big boom was in education, because using text to speech in education really helps people that have learning disabilities, low literacy levels, or dyslexia, or other disadvantages. So we saw a big boom in that space. And then after that, I mean, what happened now? Everything's really focused on voice assistants, right? But also, what we see is other things around the AI development, such as smart conversational systems in robots, like social robots, also in embedded devices, IoT. So I mean, there's never happened so much that requires text to speech than what we see today. And I think this is a very thrilling, fantastic time to be in this business, because yeah, things are happening in a very fast speed.
Because you're talking about earlier, you're talking about brands using voices to sort of brand themselves, and here you're talking about the explosion of speaking objects, robots, IoT, assistants, etc. As humans, we're, I think, sort of used to each person having a voice. Kane has a voice, you have a voice, I have a voice, and we can recognize those voices. And if Kane's voice came out of your mouth, I would be very confused. But you're only producing how many voices today?
Well, today we have around 90 different off-the-shelf voices in approximately 35 different languages. So what we focus on is to make really high quality text-to-speech voices in the languages that we support, and we constantly develop more languages as well. We will come up with a few more this year. So yeah, that's what we do. But I mean, I think it's depending really much on the application context. I mean, what kind of voice is appropriate for what kind of service or product. For example, like it's okay for a robot to actually sound robotic, because if it's like a humanoid sort of, it looks like a person, but it have clear robotic features. Well, then to sound robotic only, it's right. But then you have, if you're talking about different, like speaking styles. I mean, if you're talking about news or weather forecast, you express yourself in a certain way, compared to if you read aloud, like a audiobook or something. Or even if you look at, I mean, people that are blind or have reading disabilities, they have also digital talking books, and they are like audiobooks but without the drama, right? It should be very neutral and natural, and you should not really put any feelings into it, because it's the text, it's the content that should sort of be the bearer of emotions and feelings. You should interpret it yourself, just like normal text. So I think there's a variety of voices and voice styles and speaking styles, and there's a variety of applications. And I think it's important to mix that correctly. But we have also, I mean, we launched our new production unit called Voice Lab just a few months ago, a team dedicated to develop custom branded voices, so that if you have a very specific application context, we can sort of tailor make a very optimal voice for that.
Yeah, that's something I was curious about. If it's a potential problem for brands and consumers that, maybe my utility company uses the same voice as my credit card company, is that going to cause confusion? Is that something that it sounds like certain brands at least want to try and avoid that and have their own unique voice? Is that correct?
Yeah. But I think what will happen now is because take it back a few years. I mean, when you had the graphical, web, then graphic design was really important. Obviously, that was important even before that. So to build your brand recognition, communicate your brand values, you need to have a flashy logotype that sort of represents who you are as a company. So and that was all graphical, right? That works well in print, works well on the web. But when you're all of a sudden in a voice only context, well, then obviously you can't really see the brand. I mean, then the voice branding and sonic branding, it becomes really, really important. So customers or brands that have already like a strong jingle, they might use a specific speaker voice for their commercials, etc. I mean, they have carefully picked those voice talents to be, to have a voice that reflects the brand values, just like a logotype. And in a world of voice, I mean, how can you be seen unless you have your own characteristic special voice? You should be able to hear, yeah, that is McDonald, or that is Scandinavian Airlines, or that is this or that bank. I think that will become extremely important over time as we enter the voice only and hybrid platforms. Yeah.
Kane, outside of Alexa or Google or Siri or Bixby or those big ones, do you think there are any artificial voices that you could pick out of a lineup?
Maybe not at the moment, to be honest. But it's interesting because I can certainly pick up human voices, and because we're so kind of hardwired for audio and for speech, you can pick out a friend or a colleague or someone who you know's voice just by hearing it. And I'm wondering whether I could pick out Alexa and Google Assistant, I think, without a shadow of a doubt. And I'm wondering whether it's because we don't often hear text-to-speech voices quite as often as we hear human voices yet. Whether that's kind of what it is at the moment in terms of us not being able to identify it. I don't know. What do you think?
I think there's just one. There's just one that, because it was so tonally weird, and this goes to a little bit what you were talking about earlier, Niclas, like choosing the right voice for the right context. I don't know if they still do it, but at least in the U.S., American Express had the most unusual voice. American Express largely targeting business accounts, people who have or maybe a little more established in their careers, but their speech to text sounded like a teenager. There was always that like slight lilt at the end, like, do you want to open your account? And like there was that like a little vocal fry. And you're like, why is a teenager asking, like, helping me out with American Express? And so that one I could absolutely pick out, but it maybe sort of what you were talking about, Niclas, is perhaps choosing the wrong one is where you're becoming the most memorable.
Yeah, probably right.
Yeah.
So what's the process then to create a synthetic voice that kind of is able to read out text? Is the process different for if you were going to create one just like a synthetic voice that you would have, not based on a specific person's voice, or so for example, on the one hand, you've got like one of the Readspeaker voices that you provide, but then you've got maybe if you create a version of my voice, is there a difference in the process? And I'm wondering whether, without revealing the kind of secret sauce, whether you can kind of talk us through like what it is and kind of how it works and what the process is.
Yeah, I would say that some of our off-the-shelf voices, I mean, we've spent years on fine-tuning them and making them, super. But also, there's been a big shift in technology because from the beginning, when we started this up until just recently, we have used a technology called unit selection, which is like a concatenation of small audio snippets. So you basically record a lot of speech, you cut it up in small pieces of sound. You sort of tag them and bag them, and then you have the incoming text, and you need to sort of normalize the text. So numbers and acronyms and all that should be to have instruction on how they should be pronounced. And then you will pick, using certain algorithms, you will pick the right units sort of to make up the text that you want to have spoken, and then it's basically spoken out. And that was quite a labor intense project, and took like over half a year to make a high quality voice, be it off the shelf voice, a standard voices, or a custom voice, because there's a lot of QA, there's a lot of manually correcting all these edges in all the different audio snippets so that you don't get sort of glitches in the speech. So that was quite a handful. But in recent years, the last few years, I think it's been accelerated by tech giants like Google and Amazon, Microsoft, and IBM, among others. to use AI technology, so deep neural networks, having more big data approach to the problem, and that process is quite different. And in the voice lab now, where we create custom voices, we will also use this now moving forward for our standard voices. But then you basically have speech and text, and you put it into a sort of in a system, and you train sort of an AI with it, and after that you will have the text coming into the system. It will use one of the sort of DNN models to understand how it should be pronounced, and then it's sent to another DNN module called a neural vocoder that will form the speech signal. And where the speech signal is formed, that is sort of where you also apply the characteristics of that, the specific voice that you have recorded. But that also makes it possible to use, to tweak it, to use other people's voices with other people's speaking styles and stuff like that. So now it's just like a matter of 6 to 8 weeks for us to develop a custom voice that sounds really, really high quality, on par with the top of the market. So yeah, it's been thank you, AI and big data. Yeah.
And DNN, I'm assuming that's deep neural networks.
Yeah, correct.
Okay. So let me just make sure that I kind of understand this in my head then. So you start out with text, and that can be given to the system presumably in a variety of different ways, coming from the endpoint where whatever the system is that's feeding it. And then you break down that text into kind of its individual component parts, like it's essentially its phonemes. Is that kind of accurate? You break it down first?
Yeah, in the old system, that is how we did it, yes.
Right,
But
fair
in the new
enough.
system, it's we don't use audio snippets anymore. We just use computer models that have been trained with audio data and corresponding text. So that is the big difference. So these days we don't need to do that. That is also what speeds up the process, and also what makes the quality higher. However, it consumes much more calculating power, right? You need to have more compute intense.
So these deep neural networks have already been trained on the various different makeup of all of the various different words that exist. Is that right?
Yeah, but you don't need to have all the words. You need to teach it on how to pronounce certain combinations, so you can speak anything. I mean, if you have like a script of, let's say, 5,000 sentences that you record, and you take that text and the audio and train a model from it, and then you can feed it any text whatsoever, even though it's not been recorded, any word. But we also have certain components to be able to guess, properly guess a pronunciation based on statistics, basically. And there's a lot of nice, also some secret sauce in there, obviously. Yeah. But I mean that is how, in various shapes and forms, that is how sort of modern TTS is made. Yeah.
Okay. So you get fed text that is ran through a deep neural network that will essentially tell you how these words should be pronounced. And then after that, once you understand how it should be pronounced, you mentioned that you put essentially almost like I think of it as like CSS for audio, where you would actually make the voice pronounce things in a certain way. Is that the bit where you would kind of determine whether it's a sentence you might move up at the end, or whether it's a statement you might end it a little bit short, or how many pauses you put in it? Is that bit essentially?
Yeah, it's a very good analogy. I mean, because put this way, it's sort of, if you put in text, it marks it up with nice CSS, and then it's rendered like it's rendered in a web browser. The CSS is rendered into these nice graphics or whatever. That's what the vocoder does when it renders speech signal, and that is how you sort of apply the characteristics and the style to this signal. Yeah.
Right, interesting. How is that able to be done, or is it able to be done like on the fly, or do you need to sort of like feed it the text, then work out how you're going to pronounce it, and then distribute it? or is some of that stuff done on the fly? Like if you were to just feed it a question with a question mark at the end, it knows that and it can then behave accordingly.
Yeah, correct. So I mean, first the training of the model, because it needs to learn first. That's quite compute intense and it can take some time. But then when you feed it, let's say you can give it a whole document, and it will start speaking within like milliseconds, because it will start to generate, and it starts to ship out audio samples, so it can start to play back as soon as possible. Because of course, in any situation where the system is going to speak to or speak back to you, latency is of course quite important. It needs to be accurate. It needs to be quick. So yeah, that's pretty much how it's done.
Speaking of documents, Amazon announced recently that they have a new voice. I don't know if this was just for Alexa or was this for Polly as well, that can read longer documents, and it's a better text-to-speech at these longer documents. For someone who doesn't know, everything that goes into building these voices, why would a text-to-speech system need to handle documents differently than short text?
Yeah, I think it's about expressiveness and prosody. I mean, when we started to develop TTS, we were not really happy with the existing text-to-speech engines out there, because they were really optimized for short text. But when we were reading, literature for students or web page content, it was a lot of text. And when I say it's optimized for shorter text, it's about like a conversational system or IVR system, very short, and you have a special speaking style when you say something, short utterance. When it's a longer text, you need to have a totally different flow. So that is what we did originally, to really work on being excellent in reading long text. Because if you're good at long texts, you're quite decent in short texts as well. What we are doing now is also to develop different speaking styles, so you can use the same voice in different modes. So you can have it like we're also working with the newscaster style, or different style variations like that using the same voice. So I think that is that's important. But that's at least the difference, I would say, between short messages and longer texts. It's the flow and the prosody.
And how do you so you're kind of touching it there, like a newsreader style, a long form style, a short kind of punchy conversational style. How is it that you then kind of craft those various tones? Is it in that processing bit that you'd mentioned where you have the text rendered in a web browser and then you need to presumably find a load of newsreader content so that you understand how it should work, and then you apply that to the system? Is that roughly how it works, or how do you go about creating something that is more newsreader style?
Yeah, so I mean, we do have in some of our text-to-speech voices, we have actually a number of speaking styles, like more emotional speaking styles. It can sound like angry, sad, happy, or just neutral. And that had been done by training different sort of emotional models based on a lot of recordings. But people have basically recorded being angry or happy, or conversational, or apologetic, and stuff like that. But then, of course, you need to tell the system, because I mean, today, text to speech is, I would say, in many ways, the latest state of the art technology is better. Not better, yeah, it's actually sometimes better than real human voice, and it's basically impossible to distinguish it. But when you can sort of easily spot that this is a person, if it fails with the sort of emotional aspects, because even though a text-to-speech voice might sound great, it's not aware of what it's actually saying or the meaning of what it says. So therefore, you need to instruct it, saying, okay, this now comes a small episode. Now you should sound a bit more apologetic, because now you're bringing bad news to the user. Or now, or if in robots, where we apply these emotional styles quite a bit, the manufacturer, the programmer, need to say, okay, this is the text that should be read using this style. So you need to instruct it. So, okay, here comes something happy, here comes something angry, etc.
That's interesting. I've never thought about it like that before, that the system doesn't actually know what it's actually saying and what the thing it's saying actually means. That's such an interesting sort of observation, because that just goes to show how much you kind of can't help but personify anything that speaks. You know, you never really think about the fact that it's just kind of words that a system's reading out and it doesn't really know what it is. So that's probably the reason why there is such a push then, is that to create something that sounds more emotive or more like a news reader, or to be able to read long form content.
Yeah.
One of the things that I was wondering on, so I was using Google Assistant the other day, and I can't remember the exact thing that I said, but it ended up reading one of the things, one of the responses was something to do with Danny Minogue. Now, don't ask me why I'm searching for stuff related to Danny Minogue. I'm pretty sure it wasn't related to Danny Minogue, but anyway, the word Danny has two I's in it, Dannii.
Yeah.
And Google Assistant, I don't want to pick on it, but it pronounced it Danny I Minogue. So it said such and such Danny I Minogue. And I've noticed that a couple of times on Google Assistant recently, where I've been doing various bits of testing, and I've noticed it trip up slightly here and there. Have you noticed that, Dustin, before?
A little bit. I think one thing that I noticed, and it may be better now, but highways in the US at least, you're going to say 288 or you're going to say 35. But Google would always read it out, State Highway 288. And it's just those little things where you go, okay, yeah, this is a computer.
Yeah, and Siri does that as well. If you're using directions for Siri, it'll rather, because obviously the road names in the UK are, you get like A roads, B roads, and M roads. And the A roads are pronounced A. So when we go back up north, we drive up the A1. But Siri will pronounce it A, and it will say A1. And so if you're not paying attention, it will end up saying, go, take the next exit onto A1. And you're like, whoa, hang on, that doesn't make any sense. So I'm interested in your perspective, Niclas, in terms of like, how do you catch those things? How and what is it that's going on when we do see these kind of hiccups, like pronouncing Danny I Minogue and A1 and Dustin's example? Like, what's going on and how can you go about catching it and fixing it?
Yeah, I think since we have a history of selling web reading services to all kinds of customers in media and government and in education, we initially made the system so that we could easily create pronunciation rules that can also be context dependent. So you can say if there's especially a great example was the one university that was speech enabled all their content and all their websites, and they have different faculties, different institutions, and they might use the the same acronyms, but they mean different things, or they can so you need to have, even within one domain, you need to be able to read things differently depending on the rest of the context around it. And there's also like how we work with the homographs that are spelled, I mean, content and content, for example. What should it be? Or also like capital D and R. So is it doctor or is it drive? Well, it's depending on the context. So what we've done is to have a very powerful NLP, so natural language processing step, that can that we can over time just add more rules to it. Because one thing with the statistics only or statistical text to speech systems like the one in Google Assistant is that they are they sound pretty fantastic in some contexts, really weird in others. Like you said, if there are really things that are written in a way that you don't read it literally the way it's spelled, they usually fail because you can't add exceptions. But in our end-to-end TTS, the highest sort of quality deep learning neural TTS we have this NLP step, so we can create these or we add these context dependent pronunciations. And I mean things it's also, like I said, some words are not in the dictionaries, or you need to sort of make up how you should pronounce it, and there we have quite powerful also AI or machine learning mechanisms to guess the pronunciation. But sometimes it comes out wrong, and then we basically add it either to the dictionary or make a special rule for it. So I think we have opportunity of working with so much content really hands-on over the years. So we have, of course, created massive amounts of these, rule sets and exceptions and so forth. So if you compare the same challenging text to different text-to-speech engines, they will all read it quite differently depending on how, I would say, how good they are in a natural language processing point of view. Yeah, long answer, but
no, it's a good answer. I'm just processing it. I'm thinking I didn't actually realize that text-to-speech solutions also had a degree of NLP, natural language processing, natural language understanding, in there as well.
Yeah, because you have all the text normalization. You have you need to be able to pre-process things. If there is like in the US, I mean, the telephone number has a different certain sequence of numbers, and that you want to have read in a certain way, and a social security number in another, and there's depending on the grouping and the context in a wider scope, that you should pronounce the same or similar things very differently depending on the context. So trying to sort of learn from those and apply it instead of just sort of vanilla style, just rabble out numbers or digits, right? So try to make it best possible user experience. I think that's what we're trying to do.
We've got Michael saying hello from Chile. Hello, Michael. Carl Robinson. Shout out to Carl Robinson from the Voice Tech Podcast, joining us from Paris. Bonjour. And Simon tuning in, Simon Mackey from London. Welcome, welcome, welcome. If anyone's got any questions for Niclas, anything to do with text-to-speech, any questions that you have, fire them into the comments there on LinkedIn, and we'll put them to Niclas. We kind of touched on earlier on some of the different use cases that you're seeing in terms of where people are applying text-to-speech. And obviously, for most of the work that we do, maybe for most of the listeners tuning in, most of their kind of applications are likely to be in some kind of voice user interface, voice assistant kind of setup. In that context, maybe we can get into some other use cases kind of towards the end. It'd be nice to kind of hear a little bit more of where else text-to-speech is being applied. But for people who want to kind of build their own assistant or their own voice user interface, which we're seeing more and more and more, what is the process that they should go through in finding a text-to-speech provider? Obviously, they can just go ahead and check out Readspeaker, but what are some of the considerations that people have from the work that you've been doing over the years and working with clients? What are some of the things that people consider and need to consider when looking for a text-to-speech solution?
Well, I mean, we have worked with a few different parties that have developed their own voice assistant, for example, and then they have some of them have licensed some third-party speech to text, or they have developed their own. Sometimes, if it's kind of limited domain or limited vocabulary, that is not too difficult. NLU, some people are developing it. They have it as a platform, or they even use the big tech giants stuff. When it comes to text to speech, it's really about a few different things. First, it needs to be price versus quality. Of course, you need to score well there. We have some of the best sounding voices for some languages, and I think that shows that we can do decent quality. And then, of course, what people have been a bit, they want to be able to use the voice in any kind of application or different deployments. Because if you go to, I mean, we all know from the news that Amazon offers also custom voices now that you can actually go record with them. I think Microsoft is doing something similar, but then you're sort of locked into their environment, their platforms, and their infrastructure. Some people are not happy with that, obviously, for privacy reasons. They don't want to share the data. They want to have it run on their own servers. But also, we've had situations where people want to have the text-to-speech engine running in the device itself, so you don't really use any cloud solution. It can be on a mobile app, for example, or it can be a smart speaker, or you actually want to have it on the device. And we offer a variety of different deployment methods. And if you develop a custom voice with us, you can use it with a web API, sort of the cloud thing, but you can also run it on your own servers, not requiring GPUs even. You can run it on mobile apps. You can run it on small devices, kiosks, not connected devices even. So I think that is an important consideration, because if you make the investment of creating your own voice for your assistant or for some other purposes, you want, of course, to reuse that voice in all the different touch points that you can think of today and also in the future. And so having a supplier that can sort of fill that need, can respond to that in a good fashion. And yeah, and you need to be, I think, sorry, last thing.
No, go on. Yeah.
If you're a global company, I think it's important that you work with a supplier that is also global in nature, where we have linguistic resources. We have offices in 12 countries today, and we have a lot of in-house linguistic resources. So we can also work with multiple languages if it's required. I mean, some of the startups, they have some show some cool stuff, but it's only in English and it can only run in the cloud. I mean, and then you limit yourself. They maybe claim that you only need to have 3 minutes of audio recordings, but then the speaking style of the original voice actor will not be captured. So there's a lot of things happening out there. So just be picky, be selective, and aim for top-notch quality. Yeah.
We've got a question from Raymond in Barcelona. Did you say you were at, Raymond? Yeah, Barcelona. So you mentioned, and it's quite a nice segue, given that you kind of just referred to custom voices. He's asking that to get a custom specific text-to-speech voice for your brand, which is unique and scalable, as you were just mentioning, is it extremely expensive? And before you answer that question, I'll kind of just add, Raymond, that I've heard from people who've worked with Amazon on this, and yes, on Amazon's side, it is frighteningly expensive. So we're not asking you necessarily to reveal any costs, but is it fairly expensive today? Is it kind of reserved for those kind of like global brands? And if so, do you see the price coming down in future?
Well, I think what we try to do is to package our offering with the Voice Lab so that people can, afford to have it. And for companies and brands, it's not a big investment. I think there are also two pieces of the cost side. One is the development cost of creating the voice. Then and excluded from that is the voice actor fee, because different voice actors charge differently. If you take, I know, some super famous person or someone from the shoe shop around the corner, it will be different. But if you need to have a voice, professional voice actor, and professional studio cost. But we have different sort of, I would not say quality levels, but we have one voice is only using what is it, like 3 hours of speech data, and that basically is like 9 hours of studio time or voice actor time. And we have another that are about 10 hours of speech data. So the development cost and time is a bit different. But I mean, roughly the development costs can be around, I don't know, 40, 50k euros, which is not a lot. And of course, it depends on amount of QA and a lot of stuff. But the other side of the cost side is, of course, the licensing fee for actually then using the TTS, because the first that is pretty much like traditional text-to-speech licensing. There's sort of a minimum fee per year, but it's I mean, if you want it for an IVR or let's say for a voice assistant solution, then it's depending on the capacity. So should it be able to serve like 1,000 or 10,000 simultaneous users, then you need to have scale it for that, and you license it depending on some kind of quantity, measurable quantity. If we're going to have it, if we're going to deliver it, we're going to host the voice for you in our cloud, then it's basically a per character or per message fee. So we're very flexible. And I'm not a business guy anyway.
and a pretty reasonable price. That 40-50k is well lower than what I've heard, Dustin.
Yeah, I mean, you could buy a car, you could buy your own text-to-speech. It's a pretty good trade-off.
Yeah.
Niclas, oh, sorry, go ahead. Okay.
No. I was just going to say, yeah, no, that's about it. Yeah.
Yeah, Niclas, thanks so much for joining us. And again, thanks everyone who's on LinkedIn joining us live or joining us in the future as well. Niclas, if people want to find out more about you, find out more about your service, where can they find you?
I think the best place would be readspeaker.com, and also we have a little sort of mini site called readspeaker.ai, where we also show more of our new latest research, high quality samples, and more about custom voices.
Great.
Fantastic.
Well, thanks. Yeah, thanks so much.
Well, thank you guys. Thank you very much.
It's been a pleasure. And thank you, as Dustin mentioned, thank you everyone tuning in on LinkedIn. And we'll be back probably, Dustin, same time next week.
Yeah, let's try and make it happen.
Let's try and do it. Until next time, thank you and see you soon.